Morning. We can do.
Let's have a word of prayer. Mighty, Almighty Dad in heaven, I want to thank you for the gift of life you have offered us, God. I want to thank you that up to this moment we've given the chance to be one of the people alive. Mighty Father, as we are going to study, give us more wisdom and understanding, Mighty Father, so that we may capture whatever thing we are going to be taught by our teacher, Mighty Father. We pray that you also bless him in whatever thing he does, Mighty Father. As we are going to be taught, let's be one of those who may achieve the best, Mighty Father, through our studies. Come and be with us. We pray for your almighty power and glory to be with us. Your protection may be granted to us. I've prayed all believing and trusting in thy name. Amen.
Amen. Thank you so much, Jovix, for the word of prayer, and good morning once again. Yesterday, we started on our session on looking at the shortest distance between two lines. Yesterday, we looked at the distance between parallel lines. We went on and looked at the distance between a point and a line. And today we are going to look at the shortest distance between skew lines. So that's going to be our focus for today. And then when we finish this part, we shall go on and look at another part. So this is where we are going to start from. But before we start, when we talk about skew lines, what do we mean by skew line? When you look at the picture on your screen, I have there two loads. In real life, when we talk about skew lines, we can view them as part of the load. Like when we look at these loads, when you look at these different loads, we have a highway, like you have this load that is up, or what we can call an overpass, and we have a load that is down. Now, when you look at these two loads, we have what you call a plane. A plane is like a flat surface in two dimensions. So when you look at the load that is passing down, you can note that this load passing down here, this is a straight load and it is going in its direction. That load that is passing down. But also you notice that up there is another load that is passing, this load here that you are seeing here that is going this side. Now, when you look at this lime green line and you look at the pink line, this is one line here and this is another line. When you look at those two lines in the chart, tell me, do those two lines meet or they don't? Tell me in the chat, do those two lines meet or they don't? What do you think? They meet. Okay, I want to draw it. Now you need to, I want you to be very observant. I repeat, I want you to check the green line, the green line. Let me first clear my drawings. I want you to look at them. I want you to look at them. Check out where I'm beginning. This line here is for this. We have two loads. One is passing up, another one is passing down. So when I draw, this is one line that goes like that. You are saying? Then another load is starting from down. This load that is passing down here, like this. So it is going like that, like that, like that, and then it gets out. So my question is, do those lines meet or they don't? Very good. So everyone is noticing that those two lines are not meeting. Yes, so those lines cannot meet. Now, what we are going to look at today is going to be that particular concept, whereby you have like a plane up and you have a plane down. It can even be at the sides. It can as well be at the sides. So when they are constructing these loads, they have that in mind, that what we are constructing, that probably it should not meet. So that this is where we can have some of the applications. Another application I can give you is that when you look at the house where you are seated, when you look where you are, you can notice that you have a line up here in your house, and you have this line here. But when you try to, let me just make it a bit longer. When you look at it, members, and I make this one, do those lines meet or they don't? Those two lines I've drawn, are they meeting or they don't meet? Aha, they do not meet. They don't, right? You are right. Yes. Now, that those kind of lines that that don't meet. But at the same time, if I may ask still in the chat, when you look at the line, when you look at line AB and CD, are they parallel or not? You can even use this one. This is A and this line here. And this line here, which is B, are they parallel or not? Let me know through the chat. Are those lines parallel or not? Okay, people are saying they are not. Now, who can tell us about skew lines? Someone now who can extract the information from those two scenario, from those two things, and give us what you think skew lines are. Someone who can now create. I want you to use the first scenario I showed you, add on this property, and then we come up what we skew lines are. Anyone who can tell us briefly what you think now skew lines are? Yes, Dr. Peace.
Good morning, teacher.
Morning.
What I can say about the skew lines is that skew lines always move to different directions. So meaning that they have different parallel vectors. And therefore, we can't consider them to be parallel because parallel vectors always have similar directional vectors. But these ones,
Okay.
they move to different directions and they do not meet.
Okay. So Peace has mentioned something. He has mentioned something with parallel, and she has mentioned something with they don't meet. Thank you, Peace. Yes, Gilbert. And then lastly, Alvan. Uh-huh.
Morning, sir.
Yes, morning, Gilbert.
For me, I think skill lines,
Mm.
they aligns in most cases, they aligns in three dimension that do not intersect or meet, and they are not parallel, and yet they don't lie in the same plane.
Okay. Thank you so much, Gilbert. Yes, Alvan.
Good morning.
Morning.
Morning, sir.
Morning.
Yes, I think skew lines are lines which, first of all, don't meet but move in very different directions and are in different planes, but they don't meet. That's what I think skew lines are.
Okay, thank you. Thank you all. Yes. Now, whatever thing they have shared with us, it is true. The only thing that we are going to eliminate is going to be that those lines are parallel. But like you have looked at when I was demonstrating here, I showed you first that this line here, the first thing you need to know that the planes are different, like the surfaces, when you look at the ceiling and like the floor in your house, you can note that there is a line going up like this in like at the ceiling, and there is a line here. So when you try to elongate those lines are not parallel, and they will never meet. So skew lines, they don't meet, they don't intersect, but also those lines are not parallel. And when you view them closely, you may think that they are going to meet at one point, but actually they do not meet. So those are the lines we are going to look at. I can show you another picture such that we can visualize them. When you look at that picture, what are we going to look out for? We are going to be looking at the shortest distance. This one is plane. A plane means a flat surface in two dimensions. This is another plane. Now, when you look at the red one, this is like a line that is running like this. This is a line running like this. When you look down, there is also another line in another plane that is running like this. So those lines will go up to where they want, but they will never meet. Now, if I try now to change it, it is in 3 dimension. When I try to, you can visualize it from there. That's like when I try to open it. And then lastly, when you try to view it from up, when you try to view these lines from up, like when you try to change them, you'll as if see them as if these lines are meeting. Like when you view them from up, you'll see them as if they are meeting. So when you change this picture and you view it from up, it will appear like this. And therefore, this distance here, the yellow one, is what you call the shortest distance. At that point whereby you see as if those lines are meeting. So at that point is where we are going to base on to be able to find out what that distance is. Now, how do we find that distance? Number one, we say that whenever that shortest distance is always perpendicular. But when it comes to skew lines, this distance is perpendicular to both lines. It is perpendicular to this red and is perpendicular to this black. That means that when we are going to be calculating our distance, we shall take that into consideration. So that is what we are basically going to look at today in our session. So can you summarize something about skew lines? Just summarize something small in your book. You can write in your own words. You can feel free to write in your own words, and you can give an example to yourself. When you finish, you let me know through the chat, and then we proceed. Eh, Okay, people are saying they have finished. Yes. Shadow was asking, I saw Shadow's comment. Yes, Shadow is like when you view them in the 3 dimension, that's when they appear as if they are meeting. Like an example I gave you, I think if you were around, I showed you that when you look at this particular load, when you look at these two loads, when I draw a line like this, it will go like this. When I draw another line from down here, and I draw it like this. According to you, for you, when you observe from up, you as if you are seeing these lines as if they are meeting at this point. When you view them, you can see they can seem to be like they are meeting because here you are looking at these lines from above, but actually these lines are not meeting. One is passing down, another one is passing up, so they cannot meet. But when you view them from up, for you, you see them as if they are meeting. So that's what this third picture was trying to show you. That when you view them from up, it shows as if they are meeting. But in actual sense, they are not meeting. So that's what the third picture was showing you. Okay, so we are going to start with this number. Now you are going to allow me that we are going to utilize both methods, but I'm going to show you 2 methods, but I will emphasize one method because of the advantages I gave you yesterday over that method. Now, what do we need to do? When you look here, the first thing you need to first find out, are these lines skew? the first thing you need to look out for the direction. When you want to find out the property of given lines, you look out for the directions. So the directions, we said you look at the denominator. Look at 2, look at 3, look at -1. Look at this, and look at this. So when you look at what we have down here, I'm going to first summarize them here. I'm going to first summarize for line L1. Allow me to write here because I want to go to another screen. So when you look at L1, you note that our point on L1, which I'm going to call A, is -2, 1, and -1. Its direction, you are noticing the direction is 2I plus 3J, then minus K. When you look at L2, you notice that L2, the point I'm going to call it B, is 1, -1, and 2. When you look at its direction, you notice that, let me call this one D1, and this one I call it D2. You notice that its direction is -I plus the 2J, then plus the 4K. That is the summary of the two lines that we want to find the distance between those two lines. So allow me to use this screen now. Now, after summarizing our two lines, I can maybe draw a visual representation, but even if you don't draw, it is okay. It's like you have your first line like this. This is maybe my line 1, and I have another line like this. Which line here? This is my line L2. Now we want to find the shortest distance between the lines, assuming that this is going to be our distance that we are going to have. Now, the first thing is that first check out, are those two, when you look at the two lines, are they parallel or not? Look at the directions. When you look at D1 and D2, remember we said that for you to first check whether they are parallel, we shall set 2, 3, -1, and I have this other line, -1, 2, and 4. If I may ask, are we seeing anything which when you multiply by the first vector, you get exactly the same vector? Or are those vectors the same? Are you able to see something, or they are not? You agree that those two vectors are not parallel. Is everyone noticing that those vectors are not parallel because one is not the scalar multiple of the other? But at one point, I will also be able to show you how to check whether they intersect or not, whether they are parallel, whether they are skew or not. But that one we shall do it at a later. But one thing now I want you to know that these two lines are skew lines. So what are we going to do? Now, the first method is that yesterday we said that if you want to get the distance between any 2 points, you are going to allow me to call this point here P and to allow me to get here point Q. The first thing you are going to do is that for this particular line L1, first find out what is the coordinate at any point along that line. That is the first thing we are going to do. What is the coordinate at any point along the line? That is what I'm calling P. And then Q is that point along L2, the coordinate at that point. And we say that the first thing you can do, that you can first write your line L1 in form or in the way you understand by saying this is A plus maybe lambda times the direction. So that means I'm going to write my A, which you can write as OA. There is no problem. Even if you write your thing like OR is equal to OA plus lambda, then times the direction. It is the same. It's the same thing. So allow me to use R, and I have my OA as -2, 1, -1, plus my lambda into the direction, which is 2, 3, and -1. So we say that when we are writing our coordinate, that means we need to find out the x, the y, and the z. So our r is the coordinate, which now here we are going to call p. And always is given in form of x, y, and z. So when we simplify this side, we shall have -2 plus 2 lambda. We shall have 1 plus 3 lambda. And then I'll have -1 minus lambda. So that means that the coordinate here for P is going to be -2 plus 2 lambda. Then we shall have 1 plus 3 lambda. And then I'll have -1 minus lambda. That is our coordinate for P. Can we have someone to give us our coordinate for Q? To take us through how we can find that coordinate now for Q. Now that is for P. Can we find out Q? Anyone who wants to take us through? Okay. Yes, Linda?
For coordinates for Q
Mm-hmm.
from the formula R equals to B plus lambda D.
Okay. Can we use another parameter, not lambda, because we have used it?
Mu.
Okay, mu D,
So our R is equal to, we have 1,
Mm-hmm.
-1,
Mm-hmm.
then 2,
Okay.
plus mu, we have -1, 2, then 4.
Okay.
So R is in the form of X, Y, and Z.
Okay.
It will be equal to 1 minus lambda,
Okay.
I
Mu.
mean -1 plus 2 mu, 2 plus 4 mu.
Okay.
And our point Q is 1 minus mu, -1 plus 2 mu, 2 plus 4 mu.
Okay. Thank you. Thank you. So, members, that is always the first thing we shall always do. And let me hope we are on the same page. Now, after doing so, what are we going to do next? To get the next, remember we are looking out for this distance here. So in order for us to be able to get this distance, it means that we need to know what is vector P and Q. P to Q. That is the next thing we are going to find. So allow me to change the color and then I'll write here that now we need to find vector PQ. So I'll come and I say we need vector P and Q. So anyone who wants to take us from there? Okay. Yes, Dr. Jimmy.
Answer, should I continue from there?
Yes, continue from here. PQ, how do we get PQ?
It will be OQ minus OP.
OQ minus OP. Very good.
Therefore, we shall get this vector for OQ, which is 1 minus mu. Then down it is -1 plus 2 mu. Then we close.
Okay.
Minus 2 plus 2 mu, 2 lambda, plus, no, down it is 1 plus 3 lambda, then 1 minus lambda. Then we open the bracket. It is 1 minus it is mu plus, want it to be plus 2 minus 2 lambda.
Okay.
Then minus, down minus 1 plus 2 mu minus 1 minus 3 lambda. Then 2 plus 4 mu plus 1 plus lambda. That is PQ.
Correct like terms.
Correct like terms is 1, that is 2, no, 3 minus mu minus 2 lambda. Then that is -2 plus 2 mu minus 3 lambda. Then that is 3 plus 4 mu plus lambda.
Wow. Okay. Thank you so much. Thank you so much. So members, that's how we obtain our Q. And kindly let me know through the chat whether everyone is there on how we have gotten there.
Excuse me,
Up.
Master.
Yes.
Master, here my network maybe was not stable. I missed out the point where how do we know that these lines are skew?
Oh, now
Yeah.
skew, one of them is that you must first check whether they are or they are not parallel. And when they are not parallel, you look at the directions that are being given. So when you look at
Mm,
those directions, they're the ones that show you that actually they are not parallel, as long as one is not a scalar multiple of the other.
yeah.
But I will show you
Thank,
another property in the next session on how to
thank
prove
you.
that.
Thank you,
Okay.
Master.
Okay. Now, members, after obtaining your PQ, this PQ, this vector PQ, we say that this vector PQ is going to be is perpendicular to the direction of P. In case this is our direction of P that P is taking, this PQ is perpendicular is perpendicular to vector PQ, but still this PQ is also perpendicular to this particular line of L2. That means that we say that for any vectors that are perpendicular, the dot product is always equal to 0. Now, our vector we have obtained PQ, we are going to dot it because it is perpendicular. We are going to dot it with the direction of the first line L1, and also we are going to dot it with the direction of L2. So that's what we are going to do because those two vectors are perpendicular, and therefore we dot PQ with the direction of L1, but also we dot PQ with the direction of L2. Yes, Dr. Peace.
Teacher, I just wanted to bring in a certain idea. I don't know that it's right because I've just tried to identify it. Yeah?
Okay.
So, I mean that we are going to dot the PQ with the direction of vector 1 and vector 2, then we form two simultaneous and solve them.
Perfect, perfect, perfect.
Okay, so that's what I wanted to know.
Oh, okay. Okay, very correct. Now, members, I don't know that can I clean? I wanted to clean this side. Can I clean the other side? Do you allow me? Because I want to know, because I wanted to remove this side where I have pink. Can I clean? Okay, people are saying yeah. So allow me to clean here. I want to clean this side here since we have finished to use them. Yeah. So when I clean, it means that now we are going to come here. I still need those two things, but I'm going to clean. But I'm going to do one part, and I allow you also to do one part. So what are we going to do? Now we are going to dot. We are going to have our PQ, and we dot it with the first direction, D1. And we say that these two vectors, since they are perpendicular, we shall obtain 0. Now, sometimes, Dr. Peace, you may obtain a simultaneous equation. Sometimes, depending on the behavior of the line, you may find out that you are able to get the scalar there and there. So it will depend, but always this is a simultaneous equation that you end up with. So we shall have 3 plus 4 mu, then plus lambda. Then we dot it with the other direction of D1, which is 2, 3, and negative 1. And here we must end up with a 0. So we are going to start dotting. So when I dot, I'll have 2 into 3 minus mu minus 2 lambda plus 3 into negative 2 plus 2 mu minus 3 lambda. Okay, minus, allow me to bring the minus there. Minus 1 into 3 plus 4 mu plus lambda, I must get 0. So we are going to open up. So I'll get my 6 minus 2 mu minus 4 lambda minus 6 plus 6 mu minus 9 lambda minus 3 minus 4 mu minus lambda equals to 0. So members, can we correct the like terms? I'm saying 6 minus 6 is 0. Then here I'm saying minus 3. When I look at lambda, I want you to observe very well. This is minus 2 mu this is 6, and this is 4. So I'm noticing that mu is going to 0, and I'm remaining with the lambda. So lambda, this is minus 4 minus 9 minus lambda, which is giving me negative, is that negative 14? Negative 14. So I'm noticing that that is negative 14. So I'm going to come here and I say this is negative 14 of lambda minus 3 equals to 0. So the moment I have that, then it means that I can be able to get my lambda. So my lambda will equal to negative 3 out of 14. Okay. Yes, Dr. Olive? Dr. Olive?
Good morning, sir.
Morning.
I just wanted to know why we're using direction 1, not
We are
2.
going to use both directions because that vector is perpendicular to both line L1 and line L2.
Okay.
So we have just started with D1, but we are also going to dot with the other.
Okay,
Okay.
thank you, sir.
So members, can you be doing D2? Can you also be doing D2? You be doing D2 as well. I want, yes, Akram? Akram?
Good morning, sir.
Morning.
Sir, for me, my question is that how do you know that those lines are perpendicular? Because for sky view lines, they have to be perpendicular. So, how do you know that these lines are perpendicular?
It's not the lines that are perpendicular. Those two lines are not perpendicular. It is this line joining them. This line that you have drawn. Are you seeing this line picture? Like when I draw a line like this to
Yes,
join
sir.
the two lines, it is this
Yes, sir.
vector that I form that is perpendicular to the direction of the line.
Oh, okay. I've
Eh,
got it. Thank you,
okay.
sir.
Okay. Okay. So members, okay. So I want to write here now PQ dot D2 should give us a 0. So that is our second vector. So you be doing such that we can as well be able to obtain the value of mu. Eh, It is okay, Martina, you can run us through.
Good morning, teacher.
Morning.
So we can begin by saying negative 1, open brackets, 3 minus mu minus 2 lambda plus 2, open brackets, negative 2 plus 2 mu minus 3 lambda plus 4, open brackets, 3 plus 4 mu plus lambda. So in the open brackets, we get negative 3 plus mu plus 2 lambda plus, no, it's minus negative 4 plus 4 mu minus 6 lambda plus 12 plus 16 mu plus 4 lambda. So we're going to collect the like terms. I'm saying we have negative 3, then negative 4, and then 12. Then for the mu's, we have mu plus 4 mu plus 16 mu. Then for lambda, we have 2 lambda minus 6 lambda plus 4 lambda. So when we work with the first one, we have 5. Then for lambda, sorry, for mu, we have 21 mu. And then for lambda, we have negative 2 lambda. But then I think we're going to substitute because
Come again for lambda.
we have negative 2 lambda.
How are you getting lambda? Negative 2?
6 plus, negative 6 plus 4.
What about this?
Oh, I had forgotten that one, sorry. 2 plus 6. I'm getting 0.
0. Okay.
Yeah. So we're going to say 5 plus 21 mu is equal to 0. Then when you bring 5 this other side, it's going to become negative 5. So we remain with 21 mu is equal to negative 5. Divide both sides by 21. Then you get mu as negative 5 out of 21.
Okay. Thank you. Thank you. So, members, after you have obtained your lambda and mu, your next task is to substitute them into your PQ. So you come in PQ, you substitute them such that you can now know, what that line PQ is, what that vector PQ is. So I'm going to come here and now I substitute them. So substitute for your mu is equal to negative 5 out of 21. Substitute for your lambda is equal to negative 3 out of 14. So here you are going to put for me in your calculators now. Put in your calculators and you just tell me what we shall end up with. Me, I'm not going to put here, but I trust that I will base on the answers you get. So put in your calculator and get the answers. And don't write decimal places. Whenever you are still continuing with the number, never write decimal places. Carry on that fraction such that you are very accurate, unless when they have stated so. But if they have not, then continue using. And so we substitute. Yeah. So I'm going to wait for the answers you are coming up with. So I think I'm going to clean this area as well because I've finished to utilize it. In case you get an answer, feel free to let us know which answer you are getting for your PQ, what our vector PQ is after making your computations. Here, after substituting for your mu and lambda. You just tell us this is what I'm getting. Moses, mu and lambda, those are what? Those are parameters, eh? Okay, Dr. Peace was saying us, okay. Martina is getting, okay. Martina, you can tell us what you're getting. I'm saying you're getting 11 out of 3.
For I got 11 out of 3.
11 out of
Then
3.
for J, I'm getting negative 11 out of 6. I've not yet completed for K. Still completing.
Okay. So members, there your calculator should support you very well. Santos? Santos, you are not unmuting. Yes, Santos.
Teacher, for K, I'm getting 11 out of 6 also.
11 out of 6, eh? Okay. So members in the chat, are you getting the same things? Should we agree with
K is
Martina's?
11 out of 6.
K? Okay. Okay, Santos.
K
Okay. K is 11 out of 6.
is
Okay.
11 out
Okay.
of 6.
Okay. From the chat, it seems people are agreeing. Collins says yes. Jimmy says yes. And Robert says yes. Gilbert is getting the same. Okay. 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 I think Dr. Peace is also getting the same. Okay. Let me hope. Yes, same to Samsung, Christine, Rose. Okay. People are getting the same. So remember now, this is a vector. Now, in case they had asked you for the coordinate for the equation, remember here they can ask you for the equation of that point of intersection. That means that once they ask you for the equation, it means that for you, once you reach here, you'll just get, this is going to be the direction PQ, and you just say that now my line is going to be OP plus maybe any scale of your choice, then times PQ. Then you go there. In case they had asked for now, since they are asking us to get the distance, now members, we are going to get the distance, and we say that in order for us to get the distance, we just get the magnitude. So we shall say now PQ is equal to the magnitude of 11 out of 3 squared plus negative 11 out of 6 squared, then plus 11 out of 6 squared. Members, compute your things. Yeah. Compute, and see what you come up with. Jonathan, the same. Adrona, the same. Rose, the same. Okay. Now compute. Here now it is your calculator that supports you. So compute. When you get the answer, feel free to share with us what you are coming up with. Okay. Melissa is getting 4. Let me write Melissa 4.4907. I saw a hand. Dr. Jimmy. Yes, Dr. Jimmy. Yes, you're unmuted.
Master,
Yes.
I'm getting also the same answer. It is the square root of 121 out of 6.
Square root of 121 out of 6.
Which is 4.4907.
Okay. Martina is getting this. Okay, in simplified form. 11 out of root 6. Okay. Matia, that is okay. Just because you have a side. So then members, you make your conclusion that the distance between the shortest distance between the two lines is 4.490. If you want, you can put the word units. So it seems people are getting the same. Let me say what Samsung says. Yes, Samsung. Okay. So members, yes, Samsung?
So it's the same too.
It is the same. Okay.
Yes, I'm
Because
getting
4 point something, Okay. Then that is correct. So members, that's how you compute and get the shortest distance between any two skew lines. And if you notice, this method is the same method we used for parallel lines. The only difference is that when it comes to parallel lines, the direction is the same. So that means that you compute once for your parameter. But here, because we have two different directions, it means that you compute and get that simultaneous equation that you solve. Meaning that here, why am I still emphasizing this method? That you do not need to know very many formulas, because sometimes you may find yourself that you are confusing the formulas. That's where now the problem comes in. Yes, Esther.
Good morning, teacher.
Morning.
I didn't get the part where you talked about finding the equation of the line.
Oh, like sometimes, like when they want us to find the equation PQ, are you saying PQ is a vector?
Yes.
But in case they want us to find a vector equation, then you go back on how we get the vector equation, that you get OP, then plus a scalar, then PQ.
Oh, okay, yeah. I've got it. Thank you.
You use that concept in case they have asked you. Yes, Collins. Okay. Okay. Dr. Peace, that is okay, just because you have left a stud down, but it is well. You can remove the stud and just write it like that. Okay. Now, members, let me know through the chat. Should I show you the second approach of the formula? Say yes or no. Okay. 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 I'm saying some people are saying yes. Okay. I think yes are more than the no. Okay. So let me show you the second method of using the formula. So members, I'm going to clean my board. Yeah. Now, but in case you have mastered, though I encourage you to master the first one very well. Very well. Master it very well. Now, the second one is using the formula. Now, for the second one, I'm not going to show you how it comes about. I'm going to uh, just equate the formula, or like write the formula. This is your line L1, and this is your line, which I'm calling L2. So this is the shortest distance. Now, this shortest distance, allow me to call it P and Q, joining the two lines. Now, to find that shortest distance, which I'm calling the distance between P and Q, I'm going to come and I say, I'll get the magnitude of line PQ dot, I'm going to use N. This is vector PQ, this is vector Pn. This is dot out of the magnitude of N. But my N, this N, okay, let me first remove this. But N, this vector N stands for the cross product of direction D1 cross direction D2. That's what the N stands for. So we go back and we try it and also use this approach now. Now, when you look from our from our in fact here, allow me to let me in fact not use PQ, because I know some of you are going to stick to PQ. Allow me to use AB. Allow me to use AB. And AB is the point, is the known point. A is what you call the known point. And B is the known point on B. Because here I wanted to, now this is our distance D. Let me not use P, because now I know, because you are used to A and B. Now, in order for us to be able to get that distance from our question, you can note that we had our A was -2, 1, and then -1. We had our point B. Our point B was 1, -1, and then 2, if you remember very well. Then we had our direction, but let me just be sure. Let me go back a step back such that I write the exact thing. Yeah. Then like those who have just come in, this is where we get our A. The known point, -2, 1, and -1. Then here it is 1, -1, and -2. Then our direction for the line, which I'm calling D1, is the direction which is given by 2I plus 3j minus k. This one in the denominator. Then our direction D2 is negative I plus 2j then plus 4k. That is our direction. So allow me now to go on and compute. So what do you need to know here? Number one, you need to know how to compute the cross product. So that is our n, our vector n. So I'm going to compute the cross product of direction 1 and then the direction D2. So you remember when we are crossing, I'm going to come here and I say, this is my I, this is j, and this is k. What is our direction D1? It is here. So I'll say this is 2, 3, and negative 1. What is D2? Negative 1, 2, and 4. So then we start computing the way we compute. Can I first allow you people to compute and just give me what you are getting since we have already looked at cross product? Can everyone now compute? Eliminate I, get the answer. Like we said, come eliminate I, get the answer. So first compute for me that and you tell me what you are coming up with. You can put it in the chat and then for me I will be able to see it. Those who don't know, we said here you get the magnitude. This is 12 minus 2 of I minus j. You remove this, now have 8. That is minus 1. Then plus the k. Remove this is 4. That is what? Minus 3. So let's compute and then you tell me what you're coming up with. Compute. But knowing both method, it is very okay. It's very okay. It can save you time depending on how the scenario is. So I'm waiting for the answer you are getting for your dot product of the two directions. Okay, Melissa is getting 10, negative 7, 7. Melissa, can you check out the 10? Can you check out the 10? The two others, I may agree with you. In fact, okay, Martina 14, 14, Melissa, okay. Robert, check out the 10. 14, okay. So members, this is 14I minus 7j, Jovix, that's okay, then plus 7k. So that is our n, the vector n. Now, when you look at our formula, we need two things. One, this is your n now. This is our vector n. You need its magnitude, but also you need the dot product. So I'm going to first find the magnitude. So magnitude of n, which is going to be, so members compute it as well, plus negative 7 squared plus 7 squared. So compute that and we come up with the answer. But better, we remember I've told that if you have not yet completed the question, you are not at the final answer. Avoid writing decimals. So better here, we carry on the what? Carry on the what? The root. Whatever thing you are getting, you carry it as a root, such that you can be very accurate. So let's go on and then we compute our magnitude. So magnitude, those who have just joined, we said magnitude is just a matter of you squaring x, y, and z. Squaring x, y, and z. So this becomes x squared plus y squared plus the z squared. Okay, so this is 14 squared plus negative 7 squared plus 7 squared. So from the chart paper saying, Jovix, please don't forget. I think I'm going to first go with the root of 294. Though I think someone was summarizing, those who have the other calculators, 7 root 6. 7 root 6. Okay, Or those who have the other calculators, I know you have got something like this, which is okay. So we shall go with both of them such that we can continue. Okay, but Bettina, don't forget, don't write the points because we are still continuing. Then from there, we are going to go on and get the next thing. This is dot product. This is what? Dot product. So now I'm going to come and I say AB dot N. So our AB, we have not yet obtained it. We obtain it. We know that to get AB, you know that A to B is given by OB minus O to A. So our OB here, please take, these are the known points along the line. So we are going to have 1, negative 1, 2, minus O to A, which is going to be negative 2, 1, and negative 1. So when you subtract, 1 minus minus 2 gives us a 3. Negative 1 minus 1 gives us a negative 2. 2 minus minus 1 gives us a 3. So that is our vector A to B. Hope I'm okay. Yes, I think that's okay. Now, after obtaining this vector, we are going to dot them. So I'm going to first come with my AB, which is 3, negative 2, 3. I dot it with what I have for my N, which is 14, negative 7, and then the 7. So we are going to dot and say now this is 3 times 14 plus negative 2 times negative 7, then plus 3 times 7. Members, what do you get? That is 3 times 14 plus, that is 21. Okay. I'm coming up with 77. Hope you get the same as well. So when you dot, this is what you are coming up with. But remember, there is a magnitude. This magnitude shows you that in case you get a negative, take it as a positive. In case you dot the two vectors here and you come up with a negative, take it as a positive. An example is for someone who did BA, in case for you computed BA, here you must have gotten negative 77. So you neglect the negative and then take it as a positive. So now we shall come back and say our distance is equal to magnitude of 77 divided by the magnitude of 294. So this will give you 77 divided by magnitude of 294. And when you reduce here, I don't know, I can do the math, you can do the mathematics, but I know you get the same answer. Or for me, I can do like this, but there's no problem. I can take the 77 squared out of 294 into the root, and I end up with, this is what, 121 out of 6, which when you simplify, you get the same answer. Or you can just place your calculator and then see what you come up with. Hope members, the 7 root 6, height is 77. Just confirm that the answer, we are coming up with the same answer we had earlier on. 4.9, sorry, 4.4907 units. Yeah. Okay, the same answer, the same answer, the same. Thank you. Yes. Now, this is the second approach you can use. This is the second approach you can use. You can use the first one or the second method. I told you that the only problem with this is that you cannot be able to find the equation of the vector should they ask you that they want the equation. So that's why I'm saying that knowing both is the best. Knowing both is the best, but mastering the first one will save us a lot. Yeah, so going forward, I'm going to use only the first method. I will not be using the second method for my selfish reasons. But for you, it is okay. Always use the one that you are very comfortable with. Members, are we on the same page now? Are we on the same page? Okay, yes. Okay, let me pick a hand from Esther. Yes, Esther?
Okay, teacher, I was looking at our diagram that we had before that had P and Q, and where we had our coordinates of, okay, not coordinates, yeah, of P and then also of Q. Can't we use those as our known points?
As our?
known points.
Known points. Now, you can use those as your known points, but you don't know your lambda and mu.
So, but you'd have found it. Can't you just substitute?
From where? From where, Esther, when we are using this method?
Okay, teacher, you get your P and then you get your Q. Because your P, you had it as -2 plus 2 lambda. Can't you just fill in for the lambda and the mu, and then eventually you just use it as your known point?
Okay, now what I'm saying, Esther, when you are using, like, I'm not saying that as if you are trying to mix up the two methods. Like for the two methods here, we don't know here, like when you are using this method, you have not found out what your P is and what your Q is. So you don't know what your mu is and you don't know what your lambda is. So you cannot be able to get the equation for this line if you use, because this method here, whenever you use a cross product takes you directly to the final answer.
Yes, I've got where I've got it. Thank you.
You have understood where you are mixing it a bit.
Yes, I've understood.
Yeah. Okay, yeah.
Okay.
So here, this is how you do, and you can see it is it's, I think, much easier. The only thing you don't need to do is that now here you don't confuse, because now here you need to know that when we were dealing with with what? When we were dealing with the parallel vectors, remember for it, we were crossing, but here we do the dotting. But here also there is crossing of D1 and D2. That's the only thing now you need to know the difference. Okay, yes, Imran, as people digest.
Good morning, sir.
Morning.
Sir, my question is, for example, in the first method, why is it that when we were finding vector PQ, we had to get those coordinates from the vector equations that we had to find. Yet in this one, when we're finding vector AB, we just got what the points that we already had there. We just substituted it in. I don't know if my point is clear. Hello?
Sorry about that. So Imran, I was saying that these two approaches are different. This approach here, there is something, like I've told you, I will not show you how it comes about. But when you have A, B, and you're crossing it, remember you're crossing it with D cross D2. Here there is some mathematics we do perform. There is some mathematics we perform around here. But for you, just give you a summary when it comes to the formula. So here, this approach and the other approach, all of them lead you to the same answer. The first approach, we are using the dot product and we are deriving from the first principles. Then here, we are using directly the formula. Here we are using the formula, but deriving how the formula comes about, we cannot show you at this level. It is until you have reached a given level that now you can learn how to do it. But in the process of deriving the formula, those points you have seen are being utilized.
Okay, sir.
I don't know that you are getting it, but there are some things before you come up with the formula. Like whenever they are deriving any mathematical formula, they start from the principles, from the first principles until when they reach the final answer and they make a summary. So the first method, I was showing you how we derive from first principles. This second method just gives you the direct thing, But those points are being used, the unknown.
Yes, I now get. Thank you, sir.
Okay. Now I think members, we continue to and first read through. We can now look at a scenario. The first thing you have to pay attention to is always look at the directions. After looking at the directions, ask yourselves, are they parallel or not? That is the second question you ask yourself, that they are not. The moment you find out they are not, then that means you are good to go. So when they ask minimum distance between the bird and the drone, then that means that what has to come into your mind is that they are indirectly asking you what is the shortest distance between the two. Here, another scenario that can come is that many times you have seen that when they, I think I saw it somewhere, whereby they were rescuing someone, they had like a plane. There was a plane, and they were using also these cars, and they set off almost from the same area. So that one can come also as a scenario. Now, when you read through here, we have a drone that travels in a straight line at a constant speed. It moves with an initial point from an initial point in the direction. At the same time, another drone begins moving. A bird takes off from the initial point in a straight line at a constant speed. Find the minimum distance between the bird and the drone during this kind of movement. Yes. Okay. Let me know whether now we have read through and now we are going to start. But you can tell me which method should we stick to? Which method should we use for this number? First, okay. Yes, desire, we say that the moment they ask for the shortest distance, always the first thing you have to know is that it is perpendicular to the direction. That vector you obtain is always, yes. Okay. I'm sticking to, okay. I'm going to take the majority, what they are saying, that we use the first one. I've told you the beauty with the first one. Should the question tell you that they want also to find that equation, life will become easy. Should the question tell you that they want the coordinate, life will become very, very easy. The first one does all the things you want. The second one just takes you directly. Now, so Martina, I think learn the first one as well very well. So the first thing we have to do is that you have your drone, they have given you the direction, and they have given you the starting point. So the first thing I want everyone to do is that, can you write out the vector equation for the drone? First write out the vector equation for the drone. You have your initial point and you have the direction. First write out what is the vector equation for the drone. Yes. That is the first thing. Remember we said vector equation, we shall say your OA plus lambda times the direction. So you are going to allow me for the drone to say that R is going to be equal to the known point, which they have given us, the starting -5, 4, and -8. That is for sorry. This is 4 and then 8. Then plus our lambda into -1 to 1. That is for the drone. Then after getting the drone, I'm going to write for the bird. Here I can maybe just say this is drone, this is the bird. Still the bird is going to be your OB plus. Now since there are two different things, I'll use mu. And then come, what is your known point? 6, -4, 3, then plus mu, then the direction, which is 2, -3, and then the 4. Is that summary okay to everyone? Is that okay? That first summary of getting the vector equation for the drone and then the bird. Is everyone happy with that? Okay. Gilbert says yeah. Matthias says yeah. So I'm going to take an assumption. Colin says come again. Colin, when we are starting vectors, we say that whenever we want to obtain the vector equation of any line, we always get a known point, a point that is known, then times the parameter times the direction. Now here the known point is this initial point where someone started from. So that's what we are using. And then we write it in a vector form. So you are going to allow me now to remove this screen such that I can have now my screen bit clear. Yes. So in case you are trying to visualize it, you can even, no problem for you can come up with your simple line and you come up with another line. Now this is the starting point for the drone, which was given as negative 5, 4, 8. Negative 5, 4, and 8. This is the one for the bird, which was given as 6, negative 4, and 3. Yeah. So that is how we are trying. So now we are finding out the minimum distance in between. Okay. Yes, Gilbert.
Excuse me, master. Like that vector there, isn't it negative 5 or negative 8
It,
from
oh,
the
it is
question?
negative 8, eh?
Yeah, as if I saw negative 8 in the question.
Okay, I can go back and confirm. Okay, it is negative 8. Negative 5, 4, and negative 8. Okay, thank you. Okay, so after that, members, the next thing we have to do is we are going to find out what is this unknown point, which we call the P, and what is this unknown point we call the Q. That is always your first step you have to take, such that you know what is P and what is Q. Yes, so we said what you do now, come to your first equation and then you write your P. So members, you'll agree with me that our P is the coordinate negative 5 minus lambda, 4 plus 2 lambda, and then negative 8 plus lambda. Then our Q is the point, which is 6 plus 2 mu, negative 4 minus 3 mu, and then we have 3 plus the 4 mu. So that is our second one. Now, after getting that, the next thing you have to do is to get what is this vector P to Q. What is vector P and Q? That is the next thing you have to get. So I'm going to come and say that vector PQ is given by OQ minus O to P. So you substitute what your OQ is and what your P is. So, but here today we are going to summarize a bit. So I'm going to ask one volunteer to tell us the final answer that you will have obtained minus our OP, which is negative 5 minus lambda, 4 plus 2 lambda, and then negative 8 plus lambda. So I want someone who's to just give us the final answer after subtracting. So subtract, go through step by step for you. Yeah. Okay. Anna, yes. So subtract, and then we see what we are getting. Okay. Imran.
We have 11 plus 2, that's 2 mu? Yes, plus 2 mu
2 mu
plus lambda.
plus lambda. Okay, good.
Then the next one we have negative 3 mu
Negative 3 mu
minus 2 lambda.
2 lambda. Only?
The negative 4 plus 4 isn't that a 0?
Are we safe? Are we safe, Imran?
Oh, it is negative 8 minus 8.
Okay, so there is a negative 8, okay, something like that. Okay,
Yes.
Or I can put here -8, no problem, wherever I want. Okay. Okay, let me rewrite it again. So
Then the
this
next
is
one is
okay. The next one is
11 plus 4
mhm,
mu
mhm,
minus lambda.
minus lambda. Okay. Thank you, Imran. Okay. Members, once you reach there, you let us know in the chat. And if at all you agree with the answer, then we proceed. But those who have reached there, same answer, Jovix. Yes, there, we are there. Yeah, same. Okay, So the next thing we are going to do is now we are going to find out the dot product of our vector PQ with each of the directions. So I'm going to come now and say PQ dot the direction should always give us 0. So now we are going to get our PQ and dot it with the vector. So still I'm going to task you for me, I want the simplified equation you are going to come up with. Unless someone has a problem, that's when we shall come on to support them. Then our first direction, I'm going to use this one, which is -1, 2, and 1 should give us 0. So members, do the dot product. Remember, we are dotting. Do the dot product, and I want you to tell me just the final thing we get. But in case you get stuck, raise up your hand, and then we can do it here together. But let me first allow you to first do it on your own. Okay. I'm hoping people are making the calculations. That is the assumption I'm taking. Melissa is having -6 minus 4. Okay, -16. Okay. And Melissa, I hope that is equal to 0. Don't forget it is equal to 0. So I'm going to take on what Melissa is getting. I've seen Melissa, after making the computation, she's having -16 minus 4 mu minus 6 lambda is equal to 0. So which we are going to form now a spontaneous equation, -4 mu minus 6 lambda is equal to 16. So when you get there, then let us know. But in case you are not getting this thing like Melissa is getting, please also let us know. Another person, it is okay for you to write it as 4 mu plus 6 lambda is equal to -16. It is very okay. Okay, Jovix. Okay, that is okay. Same. Those who are getting the same now, we are going to go on to the second one now to have PQ dot the second direction D2 should equal to 0. Please, in case you are not getting, raise up your hand. Raise up your hand and then we help you. Raise up your hand and then we help you from there. So now, can you go on and dot the second vector? And those who are not getting there, also check out how are you multiplying? How are you multiplying? Let's dot the second vector. Let's dot the second vector. Okay, people are saying the same. Rose is saying the same. Gilbert the same. Abed the same. Jovix the same. Colin same. Sheba the same. Melissa same. Jesus same. Maria. These ones have not yet. Okay, Robert the same. Okay. The rest I'm going to make an assumption that we are getting the same. Okay. So we are dotting the second as well. Take your time and do step by step, step by step. Okay, I've seen an answer from Ruth. Okay, so we are going to use, let me take on Ruth and then the rest we check out. Ruth says 2 mu plus 4 lambda equals to negative 90. Okay, the rest also find out whether mu 90 plus 20 90 plus 20 mu minus 4 lambda. Martina, check out whether that is negative 4 lambda. Melissa, okay, Melissa agrees. Mattia also agrees. Jovix agrees the same. Okay, so Martina, can you first check out? Okay, yes, Jude.
Morning, sir.
Morning.
According to your vector PQ, you've written 1 plus 2 mu plus so I thought it is 11.
Which one?
On the
Oh,
first
here.
row. Yeah.
This is 11, eh?
Yeah.
Okay, sorry about that. Sorry. Okay. But hope this is what you're coming up with. Okay. Okay, thank you. On the first law, okay, you have seen the air. Same, Alvan, the same. Okay, I think members are getting the same. -4, not -6. No, Anna, I don't know where you're getting -6 and -4. Or on the first one, I get -4, not -6. Maybe you can, I don't know who that is, Anna. You can unmute Anna. Yes.
Morning, teacher.
Morning.
So, teacher, on that number, on the first one for the first direction, I'm getting -4, not -6 on what? On the lambda.
Here.
Yes.
How did you multiply members? The rest, can you go on? Okay, let me first tell the rest to continue. The rest, please continue and solve these two equations simultaneously. You can either use this equation or use this one of negative. Solve them and you'll be getting. So Anna, can you first take me? How did you multiply? Let's multiply together and see.
Yeah.
Tell me what you had.
-1 into brackets.
Mm-hmm.
11. Yeah. Plus
Mm-hmm.
2 into brackets, -8, -3 mu, -2 lambda. Plus 11. Yeah.
So when you open, what did you have?
I had -11, -2, then negative. Plus, no, minus 16, -6, -4. Then I had +11, +4, minus, because 0.
Okay. So we are interested in only what? Lambda, right? Are you
Yeah.
seeing this lambda here?
Yes.
This is 1. Where is
Like,
my pen? Oh, okay, I've got, You are seeing this lambda here?
yes.
And that is negative lambda. You are seeing this lambda here?
Yes.
And this one.
Yes.
So what do we get there?
So we get -6. So I've seen the mistake.
Okay. What was the mistake?
I had put a plus sign.
Oh, okay.
Thank you.
Okay. So members, we are solving those equations simultaneously. And at this point, I take an assumption that people know how to solve the simultaneous equations. So solve them. Ayobo Casio. What? 29 plus 4 mu. Check out how are you getting the -4? There is a problem somewhere. Ayob, if you can unmute. Ayob,
Yes.
yes. How are you getting that 4, not a 90? How have you
For that
opened?
first row, I said the lambda there is 2 lambda.
2 lambda.
Then for the second row was 6 lambda.
6 lambda.
Then for the last row was -4 lambda.
Which is okay.
Now I get 4 equals
You
4
get?
lambda. Equals 4
This
lambda.
which matches? Yes, 4 lambda is very okay.
So
Then for the mu?
for the mu, I get 4 mu for the first row. And for the second row, plus 9 mu. And for the third row is 6 plus 16 mu.
Okay, which is 0.29 mu. That is okay. Then what about for the constant now? This 11, 8, and 11. What do you have?
For the first one is 22.
22.
Plus
Plus
24.
plus 24.
Plus 44.
So when you
Which
add,
is
what do you come up with?
90.
90. So how were you getting the other 4?
I'm not sure, but I've seen. Let me
Okay.
use that.
Okay. 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 So members, solve. Yeah, So I'm waiting. Okay. From the chat, I'm not saying people are getting negative. And members here, for these meals, don't you may not actually get a good answer. Those beautiful answers you expected. You will find that your answers look a bit ugly, but it is okay. So I'm saying negative. Hey, 238 out of 79 and lambda. Eh, uh-huh. Eh, I think now solving is becoming a problem. Solving is becoming a problem. Eh, punch it in the calculator at this point. Punch it just in the calculator. I know your answers. According to Gilbert, I will agree with Gilbert. Melissa, we may not agree. There is something you are not doing right, Melissa, somewhere, somehow. Miria, that is okay. Ruth, check out. Something is not working out. Martina, check out your meal. Check out your meal. Something is not okay. Hope it's not a typing error. Jude, I agree with you. Eh, Jovix, yeah. Eh, okay, Martina. Yeah. So I don't know whether everyone is getting these ones. All we need to do it. Do we need to do it? But yeah, please use your calc. No problem. Use your calc to solve and get the answers. These are things that you should never, we should never get wrong. You can just put place in your calculator and get at least the answer and know that you are doing the right thing. People are saying the same. Now, same answers. Good. Now, we say that after getting your mu and lambda, we come back here where we have our PQ and we substitute our mu and we substitute our lambda. So I want members to come back in PQ, what we have as our PQ, and substitute for your mu, substitute for your lambda. So we are substituting now. We shall have 11 plus 2 times your mu, which is negative 238 out of 79. Now people are agreeing they have the same, minus 52 out of 79. Negative 8 minus 3 times the mu, negative 38 out of 79 minus 2 times negative 52 out of 79. Then you have 11 plus 4 times mu, which is negative 238 out of 79 minus negative 52 out of 79. Simplify. Simplify and then you get that 1. Simplify and then you tell us what you get for your PQ. Yes. And simplify. Santos 4.9. Okay, that's what Santos is getting. Santos, we are going to reach there and then we check out whether that is the answer people are getting. So simplify. So I hope you are seeing that now your skills in using the calculator should be very good. Okay, people have not given me. I wanted to check out because remember, what is your PQ? I wanted you to tell me what you get for your PQ, that vector. What is it? What is your vector PQ when you substitute? When you substitute. What do you get? Uh-huh. Okay. Ayoba has got that. Okay, Ayobo. Members, look at Ayobo's answer and then we check whether it is okay. Hmm. I'm getting the same. Okay, okay. It's okay. Uh-huh. So members have 341 out of 79, 186 out of 79, and negative 31 out of 79. Uh-huh. Yes. So members, I know now you can be able to find the length by getting the magnitude. You can be able now to get by getting the magnitude. Get the magnitude, get the magnitude. So you come up with your magnitude 341 out of 79 squared plus 186 out of 79 squared, then plus negative 31 out of 79 squared. Yeah. So from the chart, I'm seeing members are getting 4.932. 4 point. So I don't know which one is okay. The first answer I saw was 4.95. Now here I'm seeing 4.93. So which answer should we take on? But let's compute and see. In case members agree, we shall go with the answer. Put that thing in your calc. Do you agree with the answer? Collins, can you check out your answer? Santos, can you also check out? Something looks not to be adding up from what people are getting, because I'm seeing Cassio is getting 4.93, Bettina 4.93, Michael 4.93, Esther 4.93. Yeah. So I'm also going to 4.93. Okay. Members are getting 4.93, Martina 4.93. Okay. 2, 5. Sorry, I missed a step. Oh, okay. Okay, okay. Very good. Yes, yes. So the answer coming in the chat is very okay. Now, do not always forget to four significant figures. Okay, to five, I think it was 4 decimal places. Okay. Now, do not forget that you must always respond back to the item. So who can give us how you are going to conclude? Who can give us how we can conclude here now, how you're going to write your response to the item? Anyone to tell us how you would write your response? Okay, yes, Ruth.
The minimum distance between the bird and the drone during this movement is 4.9325 units. It's 4.9325, yeah.
Okay, thank you so much. Yes. So that's how you respond, and that's how you'll get that mark for responding. Yes. So that this is how they can set it like in a scenario form. And even beyond this, they can now add on other things. They can ask maybe other questions from this. So you need to know how to go about it. Yes. Okay, so in case they ask you to find the equation connecting the two, then you should be in position to know that you'll use this point. So when you find your points like this, please never feel bad. My answer is wrong. No. In fact, for these numbers, you'll find that it may not be easy for you to get those exact values of 3 to 4 like the ones you may wish. You'll find that the answers are a bit ugly. They are very large, like that. Okay, I think I want to give you some numbers for trying out. I think I'm going to clean my screen, and I don't know that you are taking a screenshot for this. Yes, now I think now you can see that now here they asked you to find the coordinates of P and Q. They asked you to find the coordinates of P and Q. And let me hope you know how to find them. Let me first take you back because now I'm not seeing something. I'm not seeing something because here, I've removed that thing. I've removed that thing. Okay, but yes, Ruth.
I mean, I was going to ask something. I joined in about like 20 minutes late. I don't know what you explained, though I had you kind of like re-explaining it. But now for that question, we have taken a screenshot. Or is it? Or is it? Okay, it shows that these lines are two. They are two of us skew, and now that they are two skew, I don't see how that PQ is directly perpendicular to that line L1 or even to
Okay.
that
Now, Ruth.
direction.
Very good. Like we said, that if I draw a line like this, and I draw a line here, this line, this vector we have obtained PQ, it is the one that is perpendicular to the direction. Not to the line, it's just perpendicular to the direction. Are you getting
But
it?
then when we're working out, we use, let me see. Oh yes, but then is it still? It's just that perpendicular that it's maybe the
To the
direction is towards the right. So we just
yes.
consider that.
Yes.
Okay, thank you, teacher.
Okay. Okay. Now, like when you look at that question, we are going to deal with, they have asked you to find the coordinates. Because now they may ask you to find the coordinates between P and Q. Now, members, when they ask the coordinates of P and Q, what you do, we have obtained our value for lambda. So to get the coordinate of P, members, you come here, substitute for your lambda, substitute for your lambda, substitute for your lambda, then get that coordinate. Then also do the same for Q. Come where Q is, substitute now, like here you had 6C plus your mu, and which was 2 times negative 238 out of 79. Negative 4 minus 3 times negative 238 out of 79. And then 3 plus 4 times negative 238 out of 79. So you get that coordinate, also get that coordinate, because they may ask you what are the coordinates. So that's how you do it. Of which now, like I'm saying, when you are using the formula, you may not be able to answer such. Okay. So I can go back now and people finish to take the screenshot. Mm. Mm. So this line here, like Ruth, you have said, it's not perpendicular. So this angle is not 90. But the direction for this L1, even if the direction is like this, they will always be perpendicular. Even if it is like this, as long as it is meeting the direction of this line, they are going to be perpendicular. Okay, so hope members, have you finished to take? Here they have asked you two things. They have asked you the shorter distance between them, and also they have asked you for the coordinates of PQ. Have you finished to take screenshot and we continue? Yeah, members, these two lines do not meet. Even if you see them like meeting, this one just crosses. Even if you see them like this, this one, like these are two different planes. This is one plane, this is one plane. Like when you look at your house at home, when you look at your house, let me use the house. When you look at your house like this, this is one plane and this is another plane. Or I can have, let me use like, I don't know. When you look at your house, you can have a line like this on one hole, and you can have another line this side. These two lines are not meeting, I don't know whether the person checking, but let me hope you have finished to take a screenshot. I wanted to show you in case there's a house format. Where is the house thing? Like when it comes to a house, when you look at this line here, for you look at it like at home. You look at it practically. Look at it practically. Even if I have like the way you see our house here, like when you look at this house, look at a line going like this. It will run like this. When I draw a line from here, like this, passing through this wall, like this, you are not seeing as if the lines are meeting, but they are not meeting. For you, when you look at it practically, draw one line this side and draw another line this side, up. You'll notice that those lines can never meet. It's just like when you look at it from above, it's like that's when you look at it at them as if they are meeting. And that is where the shortest distance is always formed. But actually they don't meet. Okay, I wanted to add you a number. Okay, let me write it here. Let me add you more two numbers that we are going to try out and then check out whether we have understood the concept. Another number, it's just, that's just direct, but just for find the shortest distance, between the following lines. So I'm going to give you this. And R equals to and then another one, this is number 2. Here, let me give you the answers such that okay, I'm just giving you. So here, you'll find your mu will be -1 out of 5 and lambda will be -7 out of 5. Then your distance here that you are supposed to get should be around 2.3664, something like that. Then the third one that we can look at, can be x. Let me use another color. Still, we are finding here you are finding still the shortest distance. X out of 2, x minus 2 out of 0 equals to y plus 1 out of 1 equals to z out of 2. And x plus 1 out of 1 equals to y minus 1 out of -3 equals to z minus 1 out of -2. So here, feel free to use any of your, but here, I know when you look at x minus 2 out of 0, don't say it is infinity. Now, because remember, this one shows you the direction. That the direction for this was in mainly two directions. This one was there, but this one was infinite. It was endless for the x component. So don't just this component is useless. No, because it is the one that is going to help you to get the direction. So still you are finding the distance between them. So yes, Jonathan, let me first take on that hand.
Yeah, good morning, sir.
Morning.
What I wanted to ask is that you said the first method helps us get the equation, but I'm not sure which equation, where is the equation?
Oh, the equation. Okay, let me first give members here. Members, whatever thing you let on, your parameters, one will be -1 and another one may be around 9 out of 7 for your parameters. And then your answer for the distance can be 3 root of 21 out of 7. Yeah. Once you get that, just know you're okay. So Jonathan, you were asking for the equation. Maybe we can put something. Find the shortest distance between the following lines, and maybe we can say the vector connecting the two lines. You can add yourself that question. Find the shortest distance between the following lines, and then maybe the vector equation joining those lines perpendicularly. So what I was saying, Jonathan, is like the way you have this. Okay, I'm going to take you. Let people first finish, and then I'm going to take you somewhere. And members, if you are finished, you let me know, and then I first do something. Okay. So I'm taking an assumption that people have finished to take a screenshot. So I wanted someone who asked for the equation. I want to use this. Where? Okay, can I use this? Or I go back to the house thing again. I come to the house. Let me use this house thing. Now, let me say they have asked you. These lines, you know that they don't meet, right? But now, in case you are finding the shortest distance, I know you would join the two lines that maybe this is where the shortest distance is. So they may ask you, what is this vector equation joining the two lines? What is the vector equation for the two lines? Now, you know very well from what we have been using. We have been using P, and we have been using what? Q. So for you to get this vector equation, remember we said that vector equation is always given by O, A, then plus lambda may be the direction. But we say that if you have 2 points on a line, like here we have P and I have point Q. If you have 2 points along that line, what do you do to get this vector equation? We say that you can just get 1 point. Let me use the P. I can just say OP plus lambda PQ. So you are going to get the coordinate of P, which I've already showed you how to get, then times lambda times your direction. Now here your direction will be P to Q, and then substitute. So that will be the vector equation. But in case they want the equation of that line joining the two, we say that when you are stating the equation of a line, always it is better you state it using a Cartesian plane. So you just turn your vector equation into a Cartesian plane, then you write something like this in this format here. And then that's where you end. I don't know whether, Jonathan, you have picked it. Jonathan, is that okay?
Yes, sir, it's all right. Thank you.
Yeah. Now, this is the same thing you do the other side. Even for yesterday, those numbers that we're asking for the equations, that is the same thing you do. That is the same thing you do. Okay. Yes, Judy.
So when you're getting the vector equation, can you also use R being equal to OQ, the vector OQ?
Perfect. OQ plus lambda PQ. It is very fine.
Okay.
It is very fine. But now here, in case you use OQ, then the best direction can be cubed P, would be the best direction. But here, any point, as long as that point is on the line, you'll get the same answers. Okay. Yes, Shadow?
Good morning, sir.
Yes, morning.
I'm having an issue on the last number which you gave us, like on the z-axis, the 11 plus 4 lambda, the mu, minus lambda. I'm getting negative 31 over 79.
Which number was that? The one we did?
Yeah, the previous one.
For which component?
One for the drone.
Like for which component are you getting that?
I'm getting negative 31. When we are trying to the vector, trying to get the vector of the PQ.
Like this one. You substituted like this.
Yes.
So this is 11. When you multiply 4 times negative 238, 238, I'm getting minus 952 out of 79. Then minus minus gives us a plus 52 out of 79.
Yes.
So when you compute this, like I can first deal with these ones. Negative 952 plus 52, I get 900. So this is 11 minus 900 out of 79. So here my LCM is 79. So 11 times 79 minus 900. So 11 times 79, which is 869 minus 900, which is negative 31 out of 79. So you are saying, oh, I don't know what. Jude, what was the question? Okay, I think members got that as the answer. Okay, I think the person was asking. Hey, okay, that was the Z component people got. Okay, yes, Jimmy?
So I don't know whether I'm now diverting you, but I had a problem with the previous exercise that we did. What does it mean? How can you show that a point is perpendicular is a foot of the perpendicular from another point?
As long as the dot product is equal to 0.
Then it is a foot.
Yes.
Because here you had told us to show that a point was A and its coordinates is the foot of a perpendicular from B, and we had those.
So that one, a line, yes. Now that one was indirectly asking you to prove that they are perpendicular. So I don't remember what number was that. What was the question saying? Show that a point A is the foot of the perpendicular from the point B to the line L to something like that.
Yes, exactly.
Now that one you had to prove. Which number? That was number 7. Yes. Now that one, what you had to do is that you had 2 points. So what I was expecting you to do is you would have obtained your A to B because you had the 2 points. You had A and B, right? So it was, you just get your A and B, or you can use B and A, and then you dot this with the direction of the line of L. So the moment you dot and you get your answer as 0, then that means that they are perpendicular. Like you have a line, and now you have you had like you have a direction for line L1, and you have another line. So you want to know that they are perpendicular. Dot this line, this vector AB or BA with this line L with its direction. It is direction that is perpendicular, and then the moment you get 0, then it means that you are safe. I don't know that that is okay. Hope you have obtained it.
Yes, it is very okay.
Okay. Shadia? Shadia?
Excuse me, sir.
Yes.
Good morning.
Morning.
So I'm still confused about how to find the vector equation with the skew lines, because if we get a point on the line, now what do we take as our direction?
Now, our direction in case these are the lines, this is your P and this is your Q, right? We say that if you have a line and you have 2 points that are known on that line, if you have, you remember when we are starting the topic, we say that if I have this is my point A and this is my point B, and I want to find out a vector, let me say this is O and this is R. To get OR, as long as you have 2 points that are known, what you do is that always get your OA plus lambda AB. But now for this case, this line that is joining the two, you have P and you have Q. Since you have already obtained P and Q, it means that here your known point you can use is P. So you say OP plus lambda PQ. So your direction is P towards Q. That is the direction you take. Hope, Shadia, that is okay.
Yes, Master. Thank you.
Okay.
So my
Yes.
question
Last
is
look.
similar. My question is
Yes.
similar. Let me just re-echo what you've said. Now, if someone chooses, okay, I'm sorry, when you were answering Jonathan, like I skipped that explanation. But if I use OQ and okay, the direction is of course no, okay. Now let's leave that. Is it a direction? Okay, let me use the mu in case I'm having mu for that side of that other line or what OQ. So instead of using lambda, I use OQ, right? I use the mu. That's my question. Should I
That
use
instead
the
of
same
what?
constant?
Lambda?
For example, if I'm using OP as my known point, not OP, but I'm using OQ. Let me repeat when I'm clear. If I use OQ as my known point, and for that side of OQ, then my direction was different.
It is okay. It is okay. Now here,
do I use another constant?
Yeah. Now when it comes to constants, for those parameters, use any parameter of your choice. You can use lambda, you can use me, you can use t, you can use m, any. It is up to you as long as you define that my t is the parameter.
Have you got my question? My
Your question
is Auntie, that we use this whatever skew lines used two constants, not one. So is it yes.
Is it?
So if someone else uses a lambda and their known point is an OA, but then is an OP or OA whatever, but then for me I have an OQ as the second skew line. Is it right for me to use lambda as my constant, or I'm supposed to go with a corresponding constant for that OQ known point?
Okay, I've gotten you. The answer, Ruth, is not really. In fact, for this new line you form, you don't use any constant you have already used. In case for line A, you use lambda. Here you use the mu. This one is totally new line. So your constant, this one, cannot be the same. So there use another letter. Is it fine?
Yeah, I've understood, yes.
Yeah,
okay.
Use totally something different.
Thank you.
Okay. Yes, Shadia. As the last person. Okay, yeah. So members, I think we are going to end here today, and then we shall start from here tomorrow. And now for people who come in a bit late, make sure we start at exactly 5. So just know that at exactly 5, the lesson has started. In fact, I don't want even to go just a minute. When even I go just a minute late, I feel very bad. So we shall start at exactly 5, and tomorrow we shall look at intersection, and we shall look at how we prove that these lines are intersecting, whether they are not intersecting. So those are the concepts we shall be looking at tomorrow. Otherwise, thank you so much for attending. Let me wish you a good day. Now, unfortunately, sometimes I fail to post those videos on they're there always on the YouTube, but in the group, sometimes I forget. So, but for you, just keep checking the group, the YouTube, you'll find them there. Okay, bye. Yes, Jimmy, a question?
Yes, sir. Hello.
Yes. Yes, please.
Tomorrow, will we study because tomorrow there is voting. I don't know whether I will be able.
Hey,